Okay, one last example for week 12 in our preparation for exam 3. A team of engineering students builds the simple seismograph shown. The coordinate xi, always says that, I don't know why. Xi measures the local ground motion, right? Kind of a thing we want to know. The coordinate x, right? So this is actually for us, this would be y. What we've been using is y. For this one, this coordinate x measures the position of the mass relative to the frame, right? So this one for us is a z, right? It's not an x, it's a z. The spring is unstretched when x is equal to 0 and the mass is 1 kilogram, and the spring constant is 10 newtons per meter, and the damper is 2 newton seconds per meter. Suppose that the seismograph is initially stationary and that at time t equals 0 is subjected to an oscillatory ground motion of, right? So this is going to be really for us, this is going to be y with respect to time is equal to y sine omega f t, right there. So our y is 10 millimeters, and our omega f is equal to 2 radians per second. What is the amplitude of the steady state response of the mass, right? So we're really looking, we're solving for z. Our natural frequency is the first thing we could do in this. So natural frequency is square root of k over m. K is 10, and our mass is 1. So we have a 3.162 radians per second natural frequency. Our R is omega f over omega n. So our omega f, as we said, was 2. Our omega n is 3.162. That's interesting. It's below 1. 0.6325 is our ratio. We could also find our damping information with a 2m omega n. 2 times the mass of 1 omega n we just found, 3.162 up above, and we get 6.324. It's kind of funny. We did that in an earlier problem where we got these two values that have nothing to do with each other, that almost equal each other. So we had the squiggle is going to be C over CC. The C given is 2. CC is 6.324, or 0.3163. All right, now we're ready, we're prepared, all dangerous and ready to go. And our equation that we'll use is Z is equal to Y, and it's going to have the R squared over the square root of 1 minus R squared squared plus 2 squiggle R squared. I'm not using yellow. So great. Z is going to be equal to, let's see. I decided to keep Y open for a moment. Not a bad idea. Our R is 0.6325 squared. And 1 minus 0.6325 squared plus 2 times our squiggle was 0.3163, and 0.6325 is that last R. Make sure you square the whole thing. So we will get a Z equals Y times 0.5547. So you can just kind of see, oh, that's how much it's going to reduce the thing. So we end up with a Z equals 10 millimeters times 0.5547, and that's 5.547 millimeters is the answer that's in the book. I like that problem. That's a pretty straightforward kind of problem, I think, to have as an exam. A 5-minute problem. All 3 problems for 5-minute problems, you'd be out of there in 15 minutes, according to math. So I'm done. Hopefully you've actually attempted some of these problems instead of watch these videos. Watching videos doesn't do you a damn bit of good. Not even a little bit. Might as well go to bed. But if you try the problems out and until you get to a solution, and then take a look, maybe zoom to the end of the video, see what the answer is. You get a lot more out of it. Have a good night.